Okay, now without any further ado, I would like to introduce to the second speaker of today's session, Mr. Avian Priyadarshi. He is already in. He has already joined the meeting. Avian Priyadarshi is promoting the services of feed milling solutions, quality management, and laboratory developments to valuable customers through EW Nutrition India Private Limited. Evan Priyadarshi is working in EW Nutrition India Private Limited and thoroughly involved and supports to feed milling solutions in animal feed industries of India, including Bangladesh, Nepal, Bhutan. He has more than 14 years of experience in this field. He focuses in the key areas of feed mill audit, operation with technical supports, quality assurance, quality control, laboratory operation, grain and raw material inspection, raw material storing, silo storing and management, etc. He is capable to handle the process and implementation of 5 years GMP, TQM, HACCP, biosecurity, hygiene, and other plant-related topics and process control, etc. His journey in this field started since 2007 to till date. He completed his master's degree in analytical chemistry and milling engineering. He began his career with Jaffa Feed India Limited, the Jaffa Group, then Godrej Limited in feed mill, quality assurance and quality control and laboratory divisions. Then he worked in aggregate consultancy and research group in research and trial division. And he was the consultant feed mill and laboratory services in Southeast Asian countries. He worked as a freelance consultant of feed milling and laboratory services for a short time. He worked in Optima Life Science Private Limited as technical manager, feed milling solutions and quality management. Now he is working in EW India Private Limited as manager of feed mill specialist in South Central Asia. He has presented papers as a speaker in different forums relating to poultry nutrition and feed milling. Now I would like to welcome him to deliver his talk on 360-degree approach of sustainable feed milling solution and quality management. Mr. Priyadarshi, now the floor is yours. Please proceed ahead with your presentation.
Good afternoon, everybody. I'm just sharing my screen. Actually, just a minute. There are some issues not opening. Okay.
Hello.
Yes, I just my screen already shared. Yes, Dr. Vivek, this is okay. Dr. Vivek.
Yeah. Can anybody help? I just. No, it's not shared. Yeah, it's shared.
Shared? Okay.
Yeah.
It clearly visible, Doctor?
Yeah, visible, but please put it in the presentation mode.
Okay. Now it's okay?
Not yet. It's still not in the presentation mode.
Okay, just a minute.
I think it will work. First, you put the slide in presentation mode and then share the screen. That way would be better, I think.
Okay. Now it's shared. This is clearly visible.
Yeah, it's visible, but still still it is not in the presentation mode.
Okay. Now it's okay.
Yeah.
Now it's,
Not yet. Not yet.
now it's
I think
okay.
you may. Yeah, yeah. It's okay now. It's fine. Please proceed ahead.
Okay. Okay. Sorry for some delay. Actually, this is not actually working. The presentation. Some might be some disturbance. Okay, no issue. And myself, Ivan Priyadarshi, the Dr. Vivek already given my already given my contents and addressed to you all the participants. And now I am presenting the 360-degree approach of sustainable feed milling solutions and quality management. So this is my topic, and I worked in these feed milling solutions and quality management related things in feed millings also in Nepal, Bangladesh, Bhutan, and India also. I was associated in some research and trial group also. For this reason, I mm, just presenting you this type of things in with simple mode with practical and ground data. In my presentation has more pictures are available and maximum minimum comments here also, and we can discuss about these points and the practical pictures. You every people sir know one feed mill but many challenges. Feed mill एक है but challenges more. One feed mill is many challenges. Which type of challenges are occurring in day to day in feed milling production and processing? Increase of raw material prices. This is the very big challenges in feed milling industries. The increase of raw material prices. The prices of raw material is not consistency in India also, and Bangladesh is Nepal is very terrible condition because here the prices is fluctuated day by day and hour to hours. You can say the increases of raw material prices is very challenging in feed milling manufacturers or feed producers, and the high processing loss. This is high processing loss is the main challenges because people are producing the feeds for birds, yeah, animals, whatever like be. But the process loss is main challenges in feed milling process because that is impact upon directly your balance sheet. The how to control the process loss, it is very challenges in feed milling. And another thing is moisture loss. There are no control in moisture loss actually. They now the raw material price is not controlled and the raw material quality is not controlled. Then moisture loss is the big challenges for feed millers and feed milling uh, works, because moistures in raw material moistures, now raw material moisture increase then down then off. That is very bad condition for the control the moisture, and the challenges is the moisture losses and also in, increase of the moisture. So that is also also challenges. And high dust and fines available in feeds. The dust and fines control is very important. This is all one of the challenge. And poor pellet quality. Poor pellet quality means we are indicating the poor pellet with the bad palatability, improper durability, pellet durability index, less hardness in the feed, the compactness of the feed, and dust also available in feed, the bad particle size distribution, the poor pellet quality we can say, and low throughput. Our plant capacity is 10 metric ton per hour, but throughput is 7 metric ton per hour. This is 3 metric tons is actually low throughput. The plant capacity of 10 metric ton, the throughput should be above 90%, means 9 metric ton to above. This is low throughput is the big challenges in feed milling, feed millers and feed milling sector. And high motor amperes. High motor amperes means we are putting more motors in feed mills. There are if you visit to feed mills, there are many motors. The motors actually the ampere is the very challenging factor, how to control the amperes through uh, with the good outputs. This is the high motor amperes is now the challenges in feed mill, and less profitability. Profitability also less for these challenges. If you can manage this, you can face this type of challenges, then profitability will be good. You know, every feed mills has more errors, issues, problems in production and processing area. Every feed mills, but how to control, that is the main things. Find out the errors, solve the problems, and save the money through the milling services, the key factor of the mills are. So how to control this type of things and to find out the errors. First things is the what is the errors. You need to find out in errors. The feed millers are buying and installing some new feed manufacture companies, the Indian companies, maybe European companies. They are install the feed mills, but they are install the feed mills, but they have many challenges. There are some errors, there are some problems. So where is the errors? That's find out the errors is the uh, uh, main challenges. Find out the errors, then solve the problems, and if you solve the problems, you can save the money. How to solve the errors and how to save the money? You know, raw material price have increased day by day. I already said the raw material price is increased day by day, and it is not in your control. But the thing which you can control, it is operational efficiency. Operational efficiency you can control in your hand. You can control your high processing loss, moisture loss, dust and fines, poor quality, low throughput, higher amperes. Everything you can control in under the operational efficiency. By improve operational efficiency, you can improve productivity and milling efficiency. If you can control the operational efficiency, you can improve the productivity and also the milling efficiency. Improvement of productivity and milling efficiency, the cost and quality in your control. If you can solve all of the challenges in feed mills, that is under your control, then the cost and quality also in your control, and that have direct effect upon your balance sheet. And these things directly effect upon your balance sheet. You can get you can control the loss and save the money in your production and from your feed mill. And feed milling challenges, I just describe the feed milling challenges. This is some bullet points I added here. Plant throughput. Plant throughput is the very big challenge. Less production as per the plant capacity. Dust issues in feed. Low PDI hardness in feeds. The PDI is also big challenges. Actually, pellet durability index is related with your particle size distribution, mixture retention, also your conditioning process. Also, that is very correlated with the gelatinization process in feed mills. The improper cooking and conditioning. The improper and cooking conditioning, actually in conditioner there have sorry. Okay. There are some noise. Okay, there are some noise. Okay. Improper
I request participants to please mute your microphone because due to the power cut of my hosting right has gone. I am through Dr. Mukul, Susim Mukul. Can you please make me co-host? If Dr. Susim is there.
Okay, no issue. We can continue, and
Okay.
Dr. B, you can make host to Dr. Saab, yeah, any other people's as per your compatibility, and I am continuing.
Okay, please go ahead.
Okay, okay. Are you fine now? Okay, doctor.
Yeah.
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 Okay. Thank you. And here is improper cooking and conditioning. Cooking and conditioning is also the big challenges in the feed mills. If you can visit to feed mills in every feed mills in India, Nepal, Bangladesh, Sri Lanka, when you can go, you can see the conditioning process is there have some errors, issues, and some challenges in conditioning process. It's actually the cooking and conditioning process also big challenges. There have some issues of in steam also, some moisture, heat, and temperature. Variety type of feed mills have variety type of challenges and variety type of issues. If we can say we are installed the good quality of feed mill and the reputed feed mill from Europe, yeah, any other countries, we can install in our plant. But there have also some conditioning issues. There have some cooking issues. What is the reason behind this? Actually, this is the reason. If you put any good quality, any reputed feed mills, that is not the issues. That the main things is how to run the feed mills and how to handle this type of things, and how to face the challenges in your feed mills. That is main things. That is main things is the finds the errors and the managing capacity in the feed mills. How to control your challenges in step by step processing, in this feed processing. And another challenges is nowadays the people's also maximum females are aware about the gelatinization. The poor gelatinization is also the challenges, and the gelatinization is actually starting in conditioning with the steam, heat, temperature, and moisture, but that not fulfilled actually after produce the feed. The gelatinization process is started, but that the gelatinization process is not completed in in the feed processing in conditioners actually. And poor emulsification. Emulsification is the challenges in feed mills. The emulsification, water and oil mixing, the emulsification challenges here, because we are adding some waters, we are adding some oils externally, also internally. There are moisture in raw materials, also water, and fat in raw materials, also oil, you can say. That is the emulsification is the big challenges. And mold invasion. Mold management is nowadays the challenges. We can control the mold also in the variety type of methods, and all people's females are aware about that. And that is main thing is we can put it the mold inhibitor to control the molds. That is the another way you can treat the mold. But main things is the mold inhibition, how you can control the access of your raw materials, how which process you received your raw materials or store the raw materials. That is the main challenges to control the mold and transit like that. After that, you can do many different things, but day fast, how you can control the mold, and how you can receive the raw materials in which process, and follow which process, and follow which type of quality control process. That is the main thing. And moisture optimization. Moisture optimization also challenges, and moisture return. Main challenges is the moisture retention and holding of the moisture. And after moisture optimization, your finished feed moisture may be 11%. If you send it to farm level, there have some farmers level, then sub-unit level, then farms level. In within this process, which how much percentage of moisture you can take from farm level? This is main important things, because if you send the 11% moisture from your feed mill, the in farm level that should be 10.7 or 10.8%. Be below 10.5, that is big challenges for the feed millers, also the farmers. This is moisture retention and holding is main challenges nowadays. And electric consumption. Actually, people are not aware about the electric consumption in feed mill. Every people are say, thinking our meter reading, our electric meter reading is our consumption. This is the bill, and we can see the this unit of electric consumed in our feed mill. But how to control the electric consumption, and which is steps and where the electric consumed through your machinery. For this reason, the main reason is the preventive maintenance can control the electric consumption, and post maintenance is different thing. And the electric, where is the electricity is consumed, and how to control. This is also the challenges. Die life and output. We are all feed millers are buying the dyes, variety type of companies. That is different thing. But which type of dye they buy, and what is the output? What is the longevity? How to handle the dye is the most important. This the how the friction of the dye, which type of production, which type of product you produce by the dye. This is the main thing: dye life and dye output. Dye, if your dye output is 10 metric ton per hour, or 9 metric ton per hour, but what is the dye life also? This is the main things. How if you produce 5,000 metric ton in a dye, either 6,000 metric ton in a dye, how much percent you can produce the dye, you can produce, you are producing from the dye. That is the main things. This is the calculation, the measurements, and also the data is very important for the dye life and dye output. Preservation of feed. If sometimes we are producing feed today, and we just storing in our godown for 7 days or 10 days or 15 days, and due to some reasons we are not capable to dispatch our feed. And the feed preservation, this is also very important. Otherwise the fungal and mold things and moisture losses is very crucial things for the feed. Actually, feed preservation is more. And biosecurity and hygiene. And biosecurity, hygiene, flushings also very important for a feed mills, because people are not aware for that. It's new environment is moving actually.
तू करना तेरे पास से
वो कार्ड मांग रहा है वो कार्ड ही ब्लॉक
तो तू पहले कैसे करती थी
Sorry, please mute. Anyone is noising actually.
Yes, sir. Actually, I'm very sorry for the disturbance because I was disconnected from my laptop, okay, and I lost my host right. Just now, I have regained my host right, and you may continue now. It will go smoothly.
Okay, no issue.
Thank you.
No issue. Okay. And the biosecurity and hygiene, this is a very important thing. Biosecurity, hygiene, flushing. People are focusing upon the farm biosecurity hygiene. They are putting some biosecurity arrangements in farms, hatchery. This is very good practice, and that should be. But in feed mill also, people should be focused upon the biosecurity and milling hygiene also. And then flushing process after change over flushings, and feed production flushings, and weekly schedules. And biosecurity hygiene is very important for the feed milling process, and for feed millers also. And other challenges are the bullet points I am discussing. The machinery related. Machinery related things is plant throughput, moisture optimization, electric consumption, dye life and output. And quality related things is dust issues, PDA harness, cooking and conditioning, gelatinization, emulsification, mold inhalation, moisture retention and holding, preservation of feed, and biosecurity and hygiene. This is the main challenges in feed mill. And this is the diagrams. The challenges is in feed mills. This is the challenges, and there are already discussed what is the challenges, and this is the solutions. So how to address the solutions? You can do the feed milling audit and scoring. Feed milling audit and scoring is the very important things, because if you audit your feed mill, you can point out your errors, then you can plan for solve the errors and issues. If you can audit or scoring, then how you can find your errors and issues. Actually there are some more hidden errors and some visible errors in you can see in the field mills. The field mill audit and scoring is a very important thing, but people are very afraid about the word of audit. For this reason, we are saying this is a field mill observation and scoring, and we'll observe your field mill and point out point out some issues or errors, and you can um, minimize your issues or errors after solve all the problems. And QAQC management is the very important things. In QAQC management, you can do the QAQC management in feed milling, storing management, raw material inspection, laboratory division. The QAQC management is very important department and also very important program in feed milling process. And laboratory audits, we are laboratory audits is very important, which process people are following, which SOP, and how to do the test. This SOP is validate or not, and the test is validate or not, and which type of equipments and chemicals they are using, and what is the actually process of receiving the raw materials, and how to do the analysis of finished feed. Is the laboratory audit is the big chapter, and for feed millers, the laboratory audit is also very important things. How to make the reports and generate the reports. How do they prepare the solutions, and how to manage the lab process. This is another chapters. This is also need for the feed millers for solve the problems and face the challenges. And raw material inspection is very important things. Raw material inspection, how to receive your raw materials. You receive the maize, soya, rice pulse, DRB, mustard, DOC, DGS, MBM, fish meal, oils, MCP, DCP, LSP, whatever you are receiving in your feed mills. The raw materials physical inspection is very important. We are suggesting first, when you receive the raw materials, you do the physical inspection first. That is, in under the physical inspection, there are some sieve tests. You can screening the raw materials first, then the some sensory test, then you go for the qualitative rapid spot test for indication which type of adulteration, anti-nutrition factor test, which type of adulteration available in raw materials. Then you go for proximity analysis, lab analysis. Then if you are available in microbial analysis, you can go for microbial analysis and generate the total reports for the raw material receiving. As like same feed after final feed also. And storing management. Storing management is very important. People are not focusing, and feed millers are not focusing upon the storing management process. If we are buying the raw materials with lower cost and good raw material also, and we are storing in our feed milling store, if we are not maintaining the storing process, how to store, actually there have some ventilation, there have some gaps to gap between the lots, the gaps between the walls, the high lot height of the raw materials stacks, and also the capacity of the raw material stacks, and the height of the raw material stacks, that is the maintain the age of the raw material stacks, cleaning, sanitation, everything under the storing management is very important thing. Otherwise you purchase the good quality of raw materials. After 7 or 10 days, the raw materials will be deteriorate for bad storing managements. And then now this is happening in the feed mills. Actually this is practical. The people are not aware about the very good storing managements. That thinking raw materials आया तो डाल दो गोडाउन में, जो देखा जाएगा उसके बाद we can do some batchings and use for in production. That is not the good practice. Storing management is a vast chapter, and it's a very good practice for store the raw materials. And the silo management. Silo management also very big challenges nowadays. Every feed millers are put their own silo, and there have silo management is very crucial chapters and very big challenges. How to control your uh, silo management process. If you receive the raw materials, you store in go down, that is visible. But if you put the raw materials in silo, that is invisible. In a vessels, you are put the raw materials in between the silo. So how to manage the silo? This is very important thing is maintain the temperature, humidity, and aeration process in silo. That is and blowing process. This is very important things for silo management. And milling solutions, process loss, preventive maintenance, milling biosecurity, safety, sanitation, and hygiene, and GMP, 5S, TQM, and others. The peoples are no need to do any other things. You should maintain GMP and 5S. First, maintain 5S and step-by-step GMP. This is very important for all feed millers. 5S and GMP. If this is not important for feed millers, you can the 5S is important for your personal life also, in your office also. Any places you can maintain the 5S and follow the 5S practice. And if you are maintain the 5S practices in your field mill, that is very good, and GMP automatically uh, follow to by 5S. There is not big issues for maintain the GMP. And the NAR services, these also the big challenges, and you can, if you can face the challenges, you should practice the NAR services also, how to maintain, how to do the analysis of raw materials and feed by the NARs, and how to maintain the NARs. This is the main things. And this is a formulation I'm just attached here. I put some medicines name also here, also some raw materials ingredients in them. Here is the targeted FCR is 1.5 to 1.6. We targeted I just mentioned here is the starter, grower, and finisher formulation and kg per ton. There have more raw materials we are used, and also here have used some ingredients and additives. How you can receive the raw materials and how you are receiving the additives also. How you analyze the raw materials and how you analyze the additives, and how you store the raw materials, and how what is your practice to store the additives or supplements. This is very important things in formulation. In formulation, you can put the kgs here, and this, and as per that the production peoples also do the production in feed mills. But how to maintain, this is the big challenges. So I am not taking more times about this formulation area. I am just shown this, and this is the raw materials. I put it the raw materials, which raw materials are using in feed mills. Basically, the feed ingredients means each of the constituents materials making of a commercial feed. This is the raw materials of maize, soybean, rice bran, DRB, rapeseed, meat bone meal, corn gluten meal, DDGS. This is the soybean is the protein source, meat bone meal, corn gluten, DDGS, rapeseed, dual type rice bran, also raw rice bran. All are protein source raw materials, and also there are maize is the energy source raw materials are indicating, and we can get some oils from raw rice bran also, and meat bone also. And this is the basic raw materials used in feed mill. And also here are full fat soya. The people are using full fat soya in Bangladesh more, and now this practice in Nepal feed mills also practiced that, and India also some feed mills are using the full fat soya where they are available. Their oil and protein you can get properly. And full fat soya crust, broken rice, wheat bran, fish meal, raw soil, limestone powder, bajra. As per zonal wise, India are using in north zone like bajra, in east zone there are no uses of bajra. And sometimes people are using, and broken rice is the good practice in feed millers. They are using the broken rice when the maize prices are increasing. And this is I am just mentioned here some raw materials pictures and the name of the raw materials, and here also jar, cotton seed meal, cotton cake, gur kurma, molasses, limestone, dicalcium phosphate, common salts. I put it here the raw materials pictures here because the raw materials inspection and how to receive the raw materials and which process you are analyzing the raw materials, which process you are follow for analysis the raw materials. This is main important things because the your feed quality actually maximum if in 100% if your feed quality is 100%, the raw material, the importance of raw materials is 50% to more. The receiving of raw materials and analysis of the raw materials is very important things for your feed quality. After that, there are some costing issues in the costing process. There are formulations and the feed milling process. But the raw materials quality is receiving quality should be good and raw material should be good. This is very important things for feed quality and quality management. And this is quality control process, how in a feed mills how you can control your quality, in which process you can control your quality. There is the quality control process. Here is the quality assurance group, quality control and analytical control. If you see the quality assurance, then you can all the audits, all the documentation, all the process oriented things, and all the SOP related things, how to develop this inspection process, how to develop the SOP, how to do the documentation process. You can all quality assurance department can do this type of things. How to develop the new process. The quality assurance team should be developed, and quality control should teams should focus upon the raw material receiving quality, feed processing quality, online process check in feed mills, and also the control the finished feeds quality, and all the quality related things. Quality control department can control these type of things. And analytical controls means that is indicating the laboratory how laboratory control this type of things, how the raw materials proximity analysis, feed proximity analysis, other plant related analysis, everything can control by the laboratory through analytical control process. This is just uh, showing this quality control process. We can manage and by three types of process: quality assurance, quality control, and analytical control. And adulteration test, yeah, anti nutritional factors test in raw materials. They have some raw materials we are using. I just in previous slide I already said we need to do the physical inspection first for the raw materials, then the anti-nutritional factor test, yeah, qualitative test, yeah, adulteration test you say. This is a very short process you can do that. Then you go for approximate analysis. As like that, I am just indicating here maize. If we are receiving the maize, we just do the adulteration test like thyram test you can do within 5 minutes. And also we need to do the we need to do the physical inspection like grain counts, mold counts, fungal, broken seed, dead seed, immature seed, and weevil source, and the small seeds. This type of things you can segregation process, we can do the physical inspection of the maize by this type of process also. And we can do the bulk density of the maize for storage in bin, like that. We can do that, the physical inspection, and also adulteration test is the theorem. If we are receiving the soya, we can check the urine activity, also the very big and very important test for soya, urine activity test, and urea also, the presence of urea or not. In all high proteins raw materials, we need to check the presence of urea. And rancidity, we can check for oil, rice pulleys, high oil raw materials. We can check the rancidity. Halts also important for rice pulleys check. Non-protein nitrogen, it is also very important uh, parameters for check the raw materials. See the high proteinous raw materials, the non-protein nitrogen is very important. The peoples are procuring some maize gluten from China. The protein percent is 70% in maize gluten, corn gluten. But if you taste the non-protein nitrogen, there have 1% non-protein nitrogen. Means 1% means into 6.25 means 6% is the protein. Here you can deduct from 17 minus 6, that is 70 64 percentage actual protein available in corn gluten. But if you consider 70% protein in corn gluten in formulation, then that is very risky for your diets. Actually, the available, yeah, non-protein after true protein, actually there is 64%. For this reason, the non-protein nitrogen is very important to management the quality of the raw materials. Tannin test, decomposition, also applicable for maize, MBM and fish meal, leather meal presence, plant protein, hair and wool, hoop and horn. This is important for the non-vegetarian sources. And mohua test for mustard, DOCR, rapeseed, aceton insoluble gums and wax for oil, and pH, TDS, total dissolved solid, total hardness for water, and which water we are using in a boiler also. The boil, that is very important things for boiler water. And CO2 reaction, that is important for limestone, DCP and calcite, grids, this type of calcium sources products. There is CO2 reaction is very important. For this reason, the manage the quality is very important for raw materials and feed also. This is the nutrition, anti-nutrition factor is important for raw materials. And here I am just showing physical inspection and quality control parameters. So what is actually your physical inspection? We already discussed about the physical inspection, spot test, and fluctuate analysis. Actually, it is indicating how to control your quality and how you can manage your quality, and what is the quality management process. If you are not target your issue, if you are not if you are not aware about which type of analysis are you doing, if you are not aware about which type of raw materials you are using in your feed, the quality you cannot control the quality. This quality management is very important things. For this reason, and the shortcut for shortcut process, I just um, attach these bullet points. Physical inspection of maize, if we already discussed, physical inspection of maize means moisture, grain counts, fungal seeds, mold seed, dead seed, immature seed, broken seed, foreign material, swivel soils, live well, smell and odor, hotness, wetness, temperature. This type of physical inspection you can do that. And physical inspection of other materials. This is the maize, and for the maize and other raw materials, you can do the 16 type of physical inspection. Things of sensory test also. Color, texture, smell, hotness, wetness, temperature, lumps, adulteration, live wells, hugs. foreign materials, over toasted, under toasted, broken rice particles, seep test, dust. This is actually some physical inspection. First, after you receive the raw materials, you can do that. And spot analysis of raw materials. So how to do the spot analysis? The spot analysis means theorem, rancidity, urea, uric activity, non-protein nitrogen, mahua, horse, decomposition, ball density. It type of spot analysis you can do. And then proximate analysis also, moisture, total ash, acid insoluble ash, crude protein, crude fiber, crude fat, calcium, total phosphorus, salt, free fatty acid, protein soluble index, non-protein nitrogen. You can do this type of analysis. Actually, proximate analysis, between the proximate analysis, you can consider the moisture, ash, sand silica, protein, fat, fiber, calcium, phosphorus, like that. But I added for other parameters is important for the feed raw material analysis. Is very important for these segments. And this is the storing go down and for raw material storing purpose. This is actually the good practice for the storing of the raw material. How to store the raw materials? You should underline, you drag the lines of the raw materials, and for do some ventilation in the raw materials stacks, and there have um, some spaces to move the raw materials, and people should be that is the good storing management process. And also silo process. Here also I just put some pictures. And this is the laboratory for analysis the raw materials and feed, how to maintain your laboratory actually. And you need to be put properly. um, the equipment should be set properly, and the chemicals should be lined up properly. The mixing solutions, which solutions you made, that should be stored properly. And the laboratory practices and the good laboratory practices also very important things for laboratory management. And we now we just see the feed manufacturing diagram. This is actually feed means edible materials which are consumed by animals and contribute energy and or any other nutrition to animals diets. Actually, in if you look the feed formulation, there have more parameters we attached in the feed formulation. If you go back in the feed formulation side, you can be here. We are using the maize for the energy source, soybean, maize gluten, raw rice bran, dual rice brans, and we are using the rapeseed, meat bone meal. Here some raw materials for energy sources, and some raw materials for protein sources, some raw materials for protein and fat sources, and some raw materials for protein, fat, and calcium phosphorus sources, like meat bone meal. Limestone also calcium, dicalcium, phosphate is a calcium and phosphorus sources, salt also, sodium chloride, soda, sodium bicarbonate. And if you look the medicines part, here is the lysine, methionine, threonine, the amino acid sources, the toxibinder, there's some multivitamins, antibacterial, and again multivitamins, mold inhibitors, trace mineral, antioxidants, enzymes. So some people are using the cocktail enzymes also, AGP, antioxidants, choline, and there's a gut health management process, and some turmeric oils. People are adding the turmeric oils also. Now, this is actually the ingredient parts, and this is the raw material parts. I'm just again I'm just here. This is actually the feed means edible materials. We are I already shown the this slides. The edible materials which are consumed by animals and contributed energy and nutrients to the animal diets. We are putted this type of raw materials and medicines, then we are getting the actually feed in this feed manufacturing process. There are some receiving points, then intake, there are grinding, there are batching and mixing, then pelleting and cooling, then packing. There are some process in this feed milling sector. There have intake points, then grinding, then batching section, then mixing section, then pelleting, cooling, then crumbling, then packing. In the feed processing diagrams, I'm just put this picture for the proper understanding. There are processing diagrams. There have raw materials, pre-cleaning, some modified feed mills, also install the pre-cleaning systems, and batching, grinding, mixing, and where is the steam addition, conditioner. In conditioner we are added the steam actually, and in mixer we are added the oils, premix, fats, water, whichever we are adding in mixture, and the cooling section, crumbling, screening, bagging. This is the feed processing diagram, and this is actually the control room of operating the total plant, how to maintain your control room. This is the safety in right. If you look the right side picture, that is the safety rooms. You can, they have stored some safety equipments for use in feed mill, and the safety is very important things in feed mills. The people, the feed millers should be aware about the safety in feed mill, safety first, and the control room should be neat and clean and properly indicated, how to maintain the control room. This is very good examples and very good pictures I attached in this presentation. The control room actually clean and under in safety conditions, and people should be aware about how to run the control room, and how to maintain the control room. This is very important in feed milling process and in feed mill. And here we just discuss about the boiler, generated steam and steaming. This is the many companies. There have more companies, boiler manufacturer companies. They are installed in boiler in feed mills. The main challenges in boiler is the steam generation, the good quality of steam generation. Here from boiler to your pellet mill, the distance is very important things, because in I observed and I seen in maximum feed mills, there are more distance from boiler to pellet mills. The steam line is very more distance. For due to more distance, the water condensed in between the steam lines, and the good quality of steams not penetrated in conditioning. Actually, this is very important things. People should be aware. And now there's some traps are already available. The boilers manufacturers also put it some traps for condensing the waters and try to penetrate dry steam, so good quality and saturated steam in condition for better conditioning and cooking process. And in boiler, the main challenges is the water. Analysis of water is very important things. How you analysis the raw waters and feed tanks waters for boiler. This is main important things. For your water quality, your steam can good, your boiler age will develop, your fuels consumption will be low. For the testing of waters and what is the value, what is the analysis values of water is the very important things. As per that, you can control all the challenges in boiler. Basically, the steam quality and the boiler age. This is depending upon our water testing, and also the low fuel consumption. This is the ideal PRX section. This is in above picture. You can see is the ideal PRS section. You need to put the steams, trap set, condenser, separator, strainer, pressure reducing valve. The PRV is very important things. Some feed mills there have no PRV. They are directly they are put at the penetrate the steam in conditioner. They have no PRV. They are not following the PRV. If available PRV, but the steam always bypass to the PRV. The PRV is very important thing to reduce the pressure of the steam pressure and control the steam pressure and penetrate in the conditioner, and that is very important thing for condensing water also. So for this reason, the ideal peer section is very important to install in feed milling, the feed mills, and this is main challenges how to how we can face the steaming challenges in feed milling process, and how to solve that. This is the ideal PR section is very important. And for the raw material batching, for weighing and batching purpose, raw material batching, actually we are doing some manual weighing by electric weighing scale. We are following the manually process also. Some manual plants, they are following the manual process, and automation plants, they are using the batching load scale for batch weighing and batching, for batching purpose of the raw materials. How to the batching systems is the control of the batching system is very important, because raw materials weighing as per formulation and dosing to grind for as per sequence of grinding process. Actually, we are first taking the formulation, and as per the formulation quantity, the feed formulation quantity, we are measuring the raw materials. That may be auto, that may be manual. If we are doing the auto, we are following the auto process, we are putting the quantity in PLC for the proper batching. As per auto, after putting the quantity, the load cell automated loaded in the cell, and the load cell weighing this and discarded the raw materials to the grinding heifer. And the calibration is very important thing for auto batching. Always the calibration is very important things. How to calibrate? If it's the two types of calibration, you can calibrate your systems, and you can calibrate it through the bypass line to measure by the manual weighing balance. This is opposite side calibration is very important. And if you are using the manual weighing balance, that should be calibrated. Otherwise, your raw materials, proper raw materials cannot weighing in this process. For batching, for good batching, you should follow the calibration of the batching systems, and weigh the raw materials as per the formulation. Actually, if your formulation, if you are in your formulation, the soya quantity is 200 kilo, but in your batching system is fault, that will be go, the soya quantity will be added in 150 kilo. The 50 kilo losses, they have quality losses. If the soya quantity will go above 200 kilo, then that also your raw material losses and overdoses of the proteins sources. And the diets formulation and diets chart will be imbalanced. And if you test, if you analyze the feed, that also some fluctuations in your analysis you can see for this batching and weighing process. And there are hammer mill. This is hammer mill, actually using for grinding purpose. And the hammer mill, there are more important things in hammer mill. uh, the hammer mill net is very important thing. Which type of net you are using, and what is the open surface and closed surface area of the hammer mill net, and what is the which diameters net you are using, and the bitter specifications are very important. And if you are using the good quality of bitters in hammer mills, and if you are using the good quality of net in hammer mills, then you think our product will be good, and our quality will be very good for these things. Because the behind of the story in the hammer mill, the hammer mill retention is very difficult things. Because after using of the good quality of net and bitter, that is good things, but what is the hammer mill retention after grinding, that should be checked for control your particles from hammer mills. That is very crucial things and important things for check the hammer mill retention from hammer mill in grinding process. And this is the batch mixture. Batch mixture also important things here, how which type of mixture are you putting in your feed meals, what is the mixing capacity, and the mixing time also is very important, the mixing sequence also very important, and which type of uh, ribbon type, yeah, pedal type, which type of um, mixing systems you are put it in your batch mixer. This is very important things. For this in batch mixture, another things also CV and the mixing time, mixing sequence, and coefficient variation in batch mixture is very important things. So we need to concentrate upon batch mixture because all oils, raw materials, and um, all additives are mixed in batch mixture actually. And this is the pellet mill for pelleting process, pelleting purpose. The pellet mill is variety type of pellet mills are available. There are variety type of conditioner also put in pellet mill. There are single conditioner, double conditioner, triple conditioners, like that. For the conditioner works is proper cooking and conditioning to the mass. And in this pelleting process, the main things are happening in conditioner actually. The main challenges in conditioner is conditioning time and the retention time in conditioner, and also gelatinization process is happening or not in conditioner. You need to be observe these key points in conditioner. After that you can get the better feed. And the important role for feed quality management is the pellet mill dye. The pellet mill dye is very, the role of the pellet mill dye is very important. We need to add about our dye, what is our dye specification, what is the compression ratio of the dye, what is actually the capacity, and which are dye materials, and uh, which type of dye we are using. And mm, basic is the relief of the dye is the very important things. We are uh, ignoring the relief of the dye. We are not ignoring, we are just in the compression ratio. What is the compression ratio we are saying, but what is also the relief of the dye that need to be included in our parameters. And for this reason, dye is very important thing for make the better feed. And also it is important for your output of the feed mills. If your dye is not good, the output will be less. And if dye is not good, the quality of feed will not be good. Basically, because the dye role is very important in feed milling process. And here is the cooler. And cooler, um, the maintaining of the cooler is the key process of maintaining of the cooler is main things is the clean the bed of the cooler, and also adjust the damper of the cooler, because the cooler blower damper, uh, we are saying the cooler damper also, that is also blower damper. We can set it properly for control the temperatures and hot air controls, like that. And the cooler management also very important, playing very important role in feed processing. Otherwise, if your feed will be hot, then that immediately affected by fungus. The chances of mold and fungus is very high. So cooling process is more important. The feed should be cool from 85 85 degree to ambient temperature. Maybe your ambient temperature is 30. If your the pellet dropped in cooler in 80 degree centigrade, then you need to reduce 50 degree centigrade by the cooler. So cooling system is very important, playing very important role in feed milling process. And this is crumbler. And crumbler, Hari, the work of the crumbler, actually crumbler is crumbling all the pellet feeds and performing the crumbs feeds as like if you say the pre-starter is 0 to 10 days, then by the crumbling process you can produce the pre-starter feed. If you go for the diets for 11 to 21 days, then that you can produce by the crumblers. Again, 21 to above days, crumbs feeds which you can produce in cooler, the crumbler. So crumbler is just making the size of the feeds as per the age of the birds and have the variety type of feed you can produce by the crumbler. So crumbler management process also important, and sometimes this crumbler is crumbler's performance also related with the feed particle site distributions. If your crumbler roller is damaged, yeah, this is not working properly, your crumbler size is not good, then the feed particle size particles will not be good. The feed particles will be uneven, that not homogeneously, and that is not same size. Actually, the particle size will be different than the standard, and it will be misbalanced with each other. So the crumbler management is also the good practices for particle size distribution, because particle size distribution also directly involved with the body weight and feed intake also. Feed intakes then body weight also. And sieve and sifters. Basically, after tumbling of the feed, we want to clean the feeds, remove the dust by this type of crumbling process. No, sorry, sifting sifter process. This is some horizontal sieve, vertical sieve. Which type of sieve we are putting, that is main important things to control the dust. Actually, we are putting the sieve, but what is the vibrating capacity of the motors, that is the main important things, and the length of the sieve and width of the sieve, this is also important things. When your pellet mill load will be more, then the sieve should be, the sieve capacity should be that should be sieve properly of the feed. Nowadays, some manufacturers are putting the low capacity of the sieve. The sieve length is very short, so there are the no space for sieving, and the sieve is like the tapered conditions, that not the floatable conditions. The degree of the sieves are matching. For this reason, the maximum dust are available in the feeds bag. The sieving system is not proper for sieve the sieving the feed. And also an important things, as per your feed, as like pre-starter, starter, finisher comes, developer, grower, as like your feed category, we need to put the net actually, and which mesh net we need to put for which type of feed. That the selection of the net is very important for the particle site, maintain the particle site distribution, and less dust in the feed. So sieving practice is very important. So this is so we need to focus on the sieving process also. And this is the packing, bagging, and stitching of the final feed. And this is a packing machines. Some people are stitching by hand. This is in manual plants, and nowadays every feed millers are put at their own automatical bagging systems, packing the bags from the beans and stitched automatically, or sometimes some hand also. There is packing and bagging system is very important, because your load scale above on the bag, where the bags are you are packing from the bags from which load cell are from the beans. There are the load cell, maintain the load cell is very important. And if you are packing the bags, we need to counter check the bags by the manual weighing scale, because if you are set the feed weight is 50 kilo, we need to pack in the bags. If your fault arising in load cell, then that maybe 52 kilo, yeah, 51 kilo, then maybe 49 kilo, yeah, 49.5, yeah, 50.5, as like that. The losses is happening in the systems. For counter check and control these type of things, we need to randomly calibrated and the load cell bagging systems, and also cross check by the manual weighing scale for proper bagging and packing. And this is the finally we are producing the feed, the mass feed. We are producing the variety categories of feeds. We are producing for layer feeds and so less in boiler feeds, but maximum producing layer feeds, and some people are producing for breeder feed also. And pre-starter comes on 0 to 10 days, and starter comes 0 to 11 to 21 days, and pellet feed is 21 to 35 days, and like that. And some we are producing the growers feeds and finisher terms, and any other steps also we are divided as like that, from 0 to 35 or 40 days. We are dividing some categories. And in Nepal, that is the practice is B0, B1, B2, B3, like that, and L1, L2, L3 layer categories like that. There is not the very crucial thing. The things is how to produce the feed in which category and as per the age of the birds. But I just put this picture for categories, three types of the feed categories. And this is the standard chart of particle size distribution. Actually, particle size distribution has no standard in worldwide. And in Kansas state of university, the researchers are saying there are no standard of particle size distribution, because your particle size distribution is depending upon your raw material formulations, your grinder net, your grinder bitter, grinder size, and also depending upon how to handle, how to test these particles. And that also one things also your crumblers, rollers, crumbler size, and the demands in markets, and what is the environmental conditions, and marketing policy. The maximum things are included in the particle set distribution. So this is the research data. Some 1000 to more data we are put here for the what is actually the basic particle set distribution. And it will be changed, it will changing day by day. But here just put the boiler feed, boiler mass feed, layer feed, and layer mass. And the hammer mill standard should be there. And how to the grinder net should be 2.5 to 3 mm grinder net we can use. And we just put it, the sieve size is not confusing. This sieve size is 2.1, yeah, 1.3, yeah, 1.5, yeah, the 3.1. This like we are not suggesting this. Just take four category of three category of 2, 1.5 if necessary for very big mass size. Then you can include the 3 mm sieve. Just ASTM, American Standard Testing Method, we need to be follow for this, and do the particle size distribution of the feed. Actually, particle size distribution is very important for the final feeds. Some feed millers or peoples are not aware about the particle size distribution, because particle size distribution, if you maintain the particle size distribution properly, your dust will be maintained properly, or every qualities you can maintain properly. And the feed texture and size should be good for the particle size if maintaining the particle size distribution. And if you follow the trial and research, a good particle size distribution, if your final feed particle size distribution is good and in range, then your feed intake will be good, and that impact upon your body weights, and also in this and improve the bird performance. You can research that. And the particle size distribution actually directly uh, impact upon the feed intake. It is very importance for finished feeds. But maximum feed millers are people are not doing the particle size distribution. Feed producing, just check the dust, it's okay. You can, but the size should be important for maintain the feed quality. And this is the summary of the how to control and what is the feed milling challenges, that is which type of challenges we are facing in feed mills, and how we can check the quality, and how to management the quality actually in feed milling process. This is online process parameters for boiler tats. Just I just attached here. uh, in summary wise, there are some components like batching, grinding, mixing the sequence here, and that's the parameters, which type of parameters, which stage, and which stage we can check which type of parameters. Like in batching, where formulation use, and which type of the formulation number, and calibration of entire measuring range. Entire measuring range means your load cell, your batching systems, your manual weighing scales, everywhere where you are doing the weighing and batching process, you need to be measured all entire calibration measuring range actually. We need to be measured. And grinding section, the sieve specification is more important things, and the hammer mill rpm, in which rpm you are crushing and grinding the raw materials. This is the very important. If you making the conditioning and steaming feed, pelleting feed, you the in high rpm is okay. If you are producing the mass feeds in varied categories, the rpm should be low, otherwise the mass size will be not perform, that will be dust. The rpm is very important things. And hammer mill vfd, variable frequency drive, which what is this, like as like the gear. Yeah, how you can control your hammer mill in your hand. That is the very challenges, and that is actually impacting your hammer mill performance and quality of the feed. Hammer mill amperes also importance for the, and the distance between hammer and screen and hammer, the distance of the hammer and screen also very important things. If you maintain the hammer and screen distance is the more, then that is the issue in performing the good grinding the good hammer milling process, and also the less so uh, issues for the hammer milling milling process. And the grinding throughput and the specific energy is also important for the grinding section, yeah, for the motors. And tip speed, hammer tip speed is also important. Now, this is a very long course upon in any one of the subjects. For this reason, I'm just not taking more time. I'm just trying to show this shortly. And mixer. This is mixer has some practical distribution, and there are some assumed value and standard. Then, and also the right side. This is the actually value, and ambient temperature, and also the delta t. Delta t is very important in grinding section. Delta t, you need to we need to maintain the delta t in grinding section also. And mixing time is very important. How to calculate the mixing time? Actually mixing time need to be calculated about your specification of the mixture. What is the rpm of the mixtures, motors, and the mixture size, and which type of mixer are you using. As per that, we need to be calculate the mixing time, and then we just check the uniformity of the mixture, as we are saying the cv, coefficient variation of the products. And here is the liquid addition, how much water we are adding in the formulation, and how much oil also we are adding in the formulation. This is very important key points: addition of water and addition of oil. How much percentage oil and water we are adding? This is directly correlated with your product quality, also the throughput of the feed mill. The how much we are producing. This is less or more, that is depending upon the liquid addition also. And moisture moisture parameters need to be checked properly in sequence wise. First we need to check the raw materials moisture, then that is the mixture moisture. Actually, after, if we are adding some waters, then need to check. Otherwise, if we are not adding any water, we also check the mixture moisture of the mixture. Then conditioner moisture, how much moisture we are adding in conditioner through steam. This is very important for cooking and conditioning. And also there is also for gelatinization also. And moisture addition through steam, how much moisture need to be added in steam in our Indian subcontinental environment. And moisture in hot pellet. Hot pellet means after pelleting, after the dye, after cleaned from dye, the moisture of the hot pellet. Actually, what is the moisture should be checked. It should be checked. And what is the cooler moisture, and what is the bagging moisture? Actually, the final feed moisture is the moisture is very important role in this feed milling process. If you are control the quality, if you are maintaining, you are enhancing your quality and want to maintain your proper feed milling solutions and quality management, then you can focus upon the moisture analyzing system. And steam quality also very important. So how much steams outlet steams from broiler, and before PRB, how much steams available in before PRB, and how much steams you are adding in conditioner after PRB. And what is the temperature also. With we need to be correlated with ambient temperature. We are adding we are saying we are adding 80-degree temperature, 80-degree centigrade temperature. We are adding 80-degree centigrade temperature in conditioner, and your ambient temperature is 30, means you are adding the 50-degree temperature in this condition. This is the ambient temperature, and the actual the adding temperature you need to be calculated always. And also that's related with the moisture also. And here is the temperature, as like how we are checking the moisture. We should side by side we just check the temperature sequentially. And dye category is a very important thing. How, which type of dye you are using, G chrome, H chrome, and variety type of dye you are using. That is single relief or double relief. And what is the dye specifications. And retention time in conditioners also very important. And LD ratio, yeah, we are saying the compression ratio, that should be maintained properly. In product wise, we can change our compression ratio, LD ratio of dye. If you are producing boiler feeds, the dye should be another compression ratio. If you are layer feeds and cattle feeds, the compression ratio of the dye should be and relief should be changed. And we, as per the feed, we need to choose our dye LD ratio, dye fair compression ratio, as like that. I'm just putting here for the ball dats here. And pellet mills throughput is very important things, and this pellet mill motor specific energy, and the pellet mill VFD, variable frequency drive, should be there. And the main motor load, which amperes they are consuming, that is actually all are things related with the your electricity consumption. And you see this electricity consumption also related your process loss. For this reason, if you properly, if you following the properly feed milling process, the process loss will be minimized. This is 100% sure. Your process loss will be minimizing if you are following the good feed milling process. People are actually every time, some people, maximum people are indicating the uh, feed manufacturing company. This feed milling manufacturing company is not good. He is not sending me good type of grinder, and their pellet mills is not good. They are not generating actually the steam properly. Actually, that is not any big faults. Main things is how you can handle the feed mills and how you can manage the feed mills and how you can run the feed mills. That is the important things. In if your max all feed millers, all feed manufacturers, all feed manufacturing company are they have some innovations. They are installing and they people are installing the plants, many more plants. They are innovation. They are not any low innovation. Yeah. Anything not like that. The people are they have R&D facility. They have good facility how to develop the feed mills and machineries. But in feed mill, after install the feed mill, we need to handle how to maintain our quality, how to maintain our machines, how to do our production with low cost. This is a main important thing. This is a maximum maximum things we need to be considered the managing of management of the feed mills, and also point out the issues and errors in the feed mills. And here the feed quality here are the PDI harness and reprocessing fines and bagging fines and also the process loss. So this is the chart of the feed milling, how this is summarized chart. If we can trace, if I can point out, if we can observe our feed milling issues and errors, where is the issues errors we can point out, then you can follow this chart and we can check step by step as per the sequence in the film. We can point out the issues and errors. Then we will try to solve how to solve these issues and errors immediately for our better feed quality and less processing loss and better feed milling solutions. And this is the end of the slide. And slide is end. I'm not taking any more times for this sector. Actually, if we'll discuss, this will be more the sequence wise and step wise of the feed milling technology. Actually, the feed milling technology is vast chapter and subject. If you discuss, this is um, we can take more times. For this reason,
Thank you. Thank you.
I already discussed with Dr. Vivek, and
Thank you very
just
much. Thank you very much, Mr. Evan Priyadarshi sir. Thank you for
okay,
your practical talk. It was a very practical talk on feed milling solution, sustainable feed milling solution, and quality management. We already have our third speaker who have joined the meeting, but we don't want to make him waited. But since there are a few very practical questions, I would like to quickly go through this question. I would like to help you. So there is a question from our respected Bharat Bhai. Could you please suggest to us how long can we keep a good condition old rice bran in our store during winter season?
okay. Okay, I am seeing these questions actually, and there are many more questions. Bharat Raj Gautam sir, okay, could you suggest us how long can we keep a good condition de-oiled rice bran in our storing during winter season? Okay, DRB. Yeah, Bharat sir is saying about DRB, the storing period of DRB in winter season. Okay, this is very good question, sir. Actually, DRB is the protein source. There are 10 to 12 or 14% proteins available. There are sometimes there is come 16 to 8% in good DRB. There have no oils also. If you are maintaining the moisture at 10 to 12 in this moisture, you can store in winter season. The stack should be, you can put it 12 to 15 height stacks for DRV in winter season. And also the time period should be, if you put that if the time period should be 10 to 12% moisture, the time you can take 1 month to 1.5 months, near about 2 months also. in winter season. In summer, that you can say 2 to 2.5 months in summer also for DRB, because if it is depending upon the actually the moisture of the DRB, which type of moisture you are taking, and which type of moisture you are maintaining for the DRB lots. And the main challenges is the ventilations and gap of between the lots. Otherwise, the weave health will be affected in DRB. For this reason, this is main things I am suggesting.
Okay, thank you. So I request Priyadarshi sir to off the presentation more so that it will look more interactive. There is another question from Rajiv sir. As we have a vibrating sieve to remove foreign particles, but not able to remove the black waves, even when we buy good quality material, what is the method of removing black color or high alpha aflatoxin waste particles?
Okay, as we have vibrating sieve to remove foreign particles, but not able to remove the culprit black maize even when we buy good quality materials. Okay, what is the method of removing black color maize particles? Okay, Rajiv sir is very practical. The question is actually we are putting the vibrator for sieve the maize before unloaded in silo. Yeah, in if sometimes we are screening the maize and collect the maize for go down storage also. But maximum practice we are unloaded the maize in silo. First we screen the maize and unloaded in silo. The all dusts can remove cobs, jutes, and stones and other irons, nails that can be removed by the vibrators. Yeah, maize sievers, yeah, maize screen. But black particles cannot be removed from the good quality of maize, because the black particle size and weights and other good quality raw material size and weights are same. You cannot remove the black maize from the screen vibrating sieve, yeah, maize siever. You can remove all the dust, cobs, other things, and small seeds also you can remove that, but black particles cannot remove. And what is the method of removing black color maize particles? That is, I have no idea any methods can remove the black color high aflatoxins type of maize from the vibrating severe screening systems.
Okay, there are a couple of questions from Singh sir. Singh sir, you can simply unmute your microphone and put them straight.
Okay, Singh sir is the legend. He actually his questions is, where is the question, sir? What is your comment on using rolling mill in place of hammer mill? Very high production per hour and very less HP used. Actually, sir, in boiler diets, maximum we are practicing using the hammer mill. If you are use the rolling mills in some other countries are using rolling mills, but in rolling mills the particle size distribution is different. And in hammer mills we are actually maintaining the coarse particles 35% and 70% is dust particles. As per the 70%, yeah, 30%, if dust particle is 30%, better steam penetration also happening, and pellet durability and proper hardness also good hardness and pellet durability also good in final feed. But if you are using the roller mill, that is challenges to maintain this type of particle size distribution in mixture या hammer mill retention in feed, and per hour and very less HP power use. Of course, sir, this is depending upon which type of hammer mill roller mill are you using, and what is the motor capacity, what is the RPM, and how to maintain. That is depending upon. But your suggestion is using roller mill is good suggestion. But in Indian subcontinent, the feed millers are not practicing. and some European countries and some European countries as using the rolling mills actually for better particle size distribution. And in the challenges in roller mill and hammer mill is, if you are using the roller mills, the dust percentage will be high. Actually, we are no need 70% to more dust in boiler feed. Actually, the pellet will be very hard, and the compactness will be not there. And after penetration, the steam penetration will be high. For this, we are not preferring the hammer mill, and the people are not practicing use the hammer mills in India and the subcontinental countries, and where they use fish fin aged in roller and shifting 3 mm to 3.5 or 4 mm sieve is done in second. Actually, no
Hello,
sieve used.
doctor. Hello. I just want to interrupt. Sorry, just to interrupt.
Okay,
Actually,
sorry.
I have seen that roller mill. I have seen that roller mill. It is still being used by buller in many countries. The roller mill, I mean the roller, I mean it is called the roller disc. That roller disc has got some kind of fish fin technology, like how the fish fin is used, like how the fins are used by the fish. The same way the rollers are made with lots of cut in all the rollers, and the distance between the two roller is 3 mm. You can actually, I mean, probably just 3 years back or maybe 4 years back, when I saw it running in a feed mill, it was costing those maybe four years back 35 lakh rupees, and it was producing 35 tons per hour. Per hour, not per hour, probably I may be mistaking. It was 30, what you call that? It was costing 35 lakh rupees, and the power use was 35 HP only to produce that feed. I mean, it was so cheap. I mean, probably we didn't have that much of capacity to produce in India. 35 tons per, I don't know, it was per hour or per batch, or I'm not able to recollect. I will send you that roller mill. I mean, the advantage of that roller mill was only that when you grain, when you try to grind that, or maybe when you use it as a roller mill, it will have a lesser powder content, because while using hammer mill, lot of particles, lot of powder comes while grinding the maize. But in this case, hardly any powder content comes, because it is it is being used in that technology. I will share with you. My only intention
Yes,
was that it uses very less power, very less power.
yes, sir. Yes, sir. Yes, sir. I am agree with you, sir. Actually, we need to go through the roller mill, and your comments is very nice, and I learned from you. Actually, I already seen the roller mills in European countries, but I have not. I have for our Indian condition, but we need to think, and if you, sir, comfortable, then
I
we can
actually
share.
I don't know how to share those pictures in that what's in this group and all. I'm not aware. I have all the quotations and all everything.
Yes.
Maybe next time or whatever I will try to share. I will try to
Yes,
share.
sir. Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you. And the questions is over. Okay, questions is over, doctor. Here, I think
Very
you
good.
should have a seed tester to check pH 7 mm to 0.6 mm. Yes, sir. This is we can check by the vibrator sieve. We can check that also. This is good idea. Also, good suggestion
No,
from
no,
you,
no,
sir.
no, no. Actually, this is about you are mentioning about the particle, standard particle size, like
Yes, sir.
standard particle size distribution. But how to
Yes, sir.
check those standard particle system? For that, there is a standard. I mean, it is a seven tier sieve is available, which probably I
Yes, sir.
brought almost 10 to 15 years back. Those days for 7,000 rupees. It is still with me. It is of a stainless steel. If you put like maybe 100 grams of particle size or 200 gram of your feed, and you there is a method of testing it, you come to know
Yes, sir.
what is the standard particle distribution in that 100 gram, so that you can take the corrective action if something less or something more.
Yes, sir. Yes, sir. I understood your question, sir.
But I think that slide was missing, how to test that particle site distribution.
Okay, sir. Okay, okay. Okay, sir. Your question is,
Hello,
sir, very useful, and thank you to all. And I'm just handovering
hello.
to
There
Dr.
is,
Vivek.
Um,
there is a question from Dr. Nirmal Vishra. He is associated with Nimbus Holdings, a very prestigious brand in the poultry feed industry. He wants to have some idea on bajra, sorghum, and fine broken rice and poultry feed.
Okay. निर्मल बिस्ता सर ने लिखा इट्स टाइम includes alternative raw material on feed. Please give some idea. Use bajra, sorghum, and fine broken rice on poultry feed. Actually, sir, this is this idea is your question is very good and your idea is very innovative. Actually, sources available source available of bajra and sorghum या fine broken rice in Nepal is very challenging. You can the available fine broken is good, but bajra sorghum is not available right now. Yeah, in future also in Nepal is very challenging process. Actually, in if you see in North India, the feed mills are using bajra sorghum like that. But in East, if you come in East India, there are no uses of bajra, only maize and broken rice. Uh, Bajra maybe sometimes the maize rate will be increased, then the people are thinking about bajra. Otherwise, they are using the broken rice and maize like that. Okay, this is your question is good. You can use, but your feed color will be uh, dark, and you need to put more turmeric oil in your feed for the yellowish color. Actually, Nepal, the farmers are very very much more aware about the color of the feed. Actually,
Thank you. Thank you very much. Thank
Hello.
you very much.
Um,
Yeah,
uh,
yeah, yeah, sir.
uh,
Please.
Hello. Are you getting my voice, sir?
Yeah, yeah.
yes,
Yes, sir. So my name is Harjot Singh, and I'm from Larkinsling, India. I've heard the discussion between Dr. Saab, AVNG, and the respected Onkar ji regarding the roller mill and the hammer mill. I just need 2 minutes from both of you. Our company had a small study over the hammer mill and the roller mill. If you allow me, I can share my views. Just I need 2 minutes, sir.
Sure, sure.
okay, sir. No issue, no issue. You can share.
Actually, sir, we do supply machines in feed mills and the breweries and the ethanol companies. Where the in breweries and the ethanol producing from the maize and the broken rice, where there is only single product having a ideal moisture content, and where there is the particle size is very important. For example, in poultry or the feed milling, if there is a range between 400 to 900 microns that can be produced in the feed mill. But in some applications in breweries and ethanol producing companies, there is fixed particle size, very limited range of particle size required to get the maximum fermentation of the grains. So here there is single product with single particle input and the average ideal moisture. Roller mill is best suited because it reduces the dust percentage. Because in hammer mill, if we uses even the coarse feed, a coarse screen like 5 or 6 mm, there is no
Hello.